Hello there, this is Stephen McDonnell, and what this is showing you is a snapshot of the work that's going on in my lab at the moment. I'm going to talk you through clockwise, starting with the top left. What we do in our group is look at surface and interface chemistry and how that relates to the functional properties of materials in a range of device applications. And then we also look at engineering those surfaces and interfaces. In recent years, we've been focused primarily on two-dimensional materials. In the top left there, you're seeing some examples. These can be insulators, conductors, semiconductors. What they all have in common is van der Waals bonding out of plane, which means that they can be stable even down to one monolayer because there's no dangling bonds. That middle slide at the top there is showing you the UHV system that we use. We can synthesize two-dimensional materials using molecular beam epitaxy, and then we can study the chemistry, the surface structure, the electronic structure even, all without ever breaking vacuum. Now, the top right there, you're seeing some work that's recently been done by Gabby. She's interested in niobium silicon Schottky diodes, and the Schottky barrier is related to the work function of the niobium. And what she's been looking at is how that niobium work function depends on oxygen exposure. And so the spectra there on the right-hand side are showing you just how sensitive it is. She can vary the work function by over 1 eV by exposing it to different concentrations of oxygen. In the bottom left, Peter's been looking at the growth of these 2D materials by MBE, showing how the morphology and grain size depends on growth temperature, and also showing that we can get electronic structures that match up with theory very well. That's what you're seeing in the bottom left there. Bottom middle is being done by Meg Sales. She was looking at the thermal stability of ferroelectric insulators on these 2D materials. That lack of dangling bonds on the surface means that things don't stick to them very well. And she's been showing that you got to do a lot of tricks to get it to stick. In the bottom right, that is being done by Lee Kendall. He's been growing MOS2 by a different method. He's been doing electrodeposition, and in collaboration with the Giovanni Zangari group, because he's co-advised by Professor Zangari, he's also looking at the photoelectrochemical activity of these materials and relating it back to surface chemistry.